if my computer comes alive. I'm going to talk a little bit about one of my pet peeves. This does not necessarily deal with operational networking. Ed Kern, where are you? There are no operational components to my talk, so you can just leave now. I'm going to talk a little bit about RFC 1918 use in the Internet and then touch briefly upon IPv6. One of these groups of addresses has more use than the other in the Internet today, and I'll leave you to judge the impact of that. Who doesn't know what RFC 1918 space is? Anybody not know? Okay, that's what it is. It's those ranges of addresses. They are delegated for use in private networks. This is what they're supposed to do. This is from the RFC. They are to be unique within an enterprise or a set of enterprises which choose to cooperate, but it's private, i.e. it's not supposed to appear in the big I public Internet. And these are for nodes that cannot have IP connectivity to any host outside of the enterprise or groups of the enterprise. These are numbers that should not be visible. You shouldn't see them on the Internet. They shouldn't appear in the routing tables. The RFC is not clear on a couple of issues. One of them is, should they appear in email headers? And should they appear in DNS queries? Application level use of this stuff. The general idea, to my mind, is that no, they shouldn't, but they do. And I raised my concerns with the guy who was my boss, John Postel, and he agreed that it would be prudent to have a backstop, if you will. There were some concerns about automated registry functions and an enterprising ISP turning in a delegation request to Network Solutions and having 1918 space name server set up. So he said we should probably do that ourselves. And so these prefixes are actually delegated to real name servers in the big I Internet. And the servers are authoritative, but they were initially set up to not provide any data other than, yes, I'm the name server for this space, but there's nothing here. What happens is, and this is the tiny pinhole view I have, and we'll talk a little bit about that in the next couple of slides, is that leaks in firewalls show up in the DNS logs on these servers in attempting to get name resolution. The first couple of years, the logs were pretty empty. But there were some people that said, you know, you really should provide a real answer. So we tried to do that. One morning after we got what I thought were the appropriate permissions, we wildcarded all responses, all PTR answers for these prefixes to say, read RFC 1918 in a somewhat more polite fashion, thinking that this shouldn't be a real problem. Well, it turns out that a couple of 3 or 4 of the big network management vendors use 1918 space to communicate between their probes and the collection agents. And for a couple of large corporations and large enterprises, their network management maps collapsed to a single data point that said read RFC 1918. I don't like getting calls from the president of my university. It was backed out in a couple of hours. So we are in the situation where these name servers still are authoritative, but they do not have real data. It's basically, we're authoritative, there's nothing here, go away. This stuff shows up in logs, not only in our logs, our DNS logs, but it shows up in Firewall 1 and Black Ice and half a dozen other things as looks like penetration attempts because the name servers are attempting to respond to the queries. So we now spend a lot of time answering that kind of email. No, we're not attacking your systems. Go away. Read the RFC. So what's there? We're getting between 1 million and 2 million queries per day on the name servers, which leads me to believe that there is a significant amount of RFC 1918 usage that is misconfigured. even though these things are misconfigured, and it's probably useful to encourage people to set up their access stuff appropriately, one of the more interesting things is, well, RFC 1918 space covers three address ranges. Which ones are the most popular? So I looked at this by prefix, and by far, the most popular 1918 space that is misconfigured is the 192.168 space, almost by an order of magnitude more than the 172.16 space. And that 10 is right up there. So that actually tells me that what is using this, or what the distributions are. I actually have the raw data to actually go in and say these individual prefixes, which are the internet side of the firewalls, are leaking. Or actually what we discovered in the case where we actually provided answers, the state of California was using 1918 space on their internal networks which were not firewalled from the rest of the network. They since actually put up firewalls for that. So this is sort of the distribution of 1918 space. Question I have is, would it be prudent or useful to this community to go in and do more detailed analysis and aggressively encourage people to block this from showing up on the net? And I'd be willing to take take answers later on that. So that's that 1918 space usage. Questions? Any other way that I could get this data? Is it useful? I can't see anybody, so. Okay. I'm going to look at, sure. I'm going to look at some of the IPv6 delegation history. IPv6 is maybe 3 years younger than 1918 space. And it's had a number of large, basically, entry points for delegation. And so in the IPv6 visible world, you'll see at most 3 distinct large prefixes. There are 2 test prefixes. The original one is f.5.ip6.int, and that had some auto-configuration stuff. So if you had an autonomous system number, you could get IPv6 prefixes simply by doing some simple math to encode your AS and then attach it under this f.5ip6.int. That has been phased out as far as I can tell, but it hasn't been formally declared dead. But few people will route it. It has been replaced by the EFF3.ip6.int delegation, which is for the 6-bone. So if you go to the 6-bone web pages, you talk to folks inside the IETF, this prefix is used by folks who are interested in getting IPv6 visibility, a little bit of understanding about how things work. And this was pretty much valid up through this time last year. There's a transition delegation, which is the 6-to-4 transition prefix, which is 2.0.2. And that was actually formally documented in August of 1999. The registries themselves got their delegations lined up in June. And they have 2 consecutive blocks. ARIN has 4 and 5. .0.1.0.0.2 IP6int. RIPE has 2, and APNIC has 2. If you walk the DNS delegation hierarchy, you'll find that ARIN has not registered any delegations in its name servers for delegations it has made. RIPE has delegated 19 blocks, and APNIC, for the Asia Pacific region, have delegated 5. If you check the registration delegation database, the WHOIS database, you will find that their numbers don't match with these. More delegations are being made without active name servers. And I find that to be sort of problematic. What that says is that the European community is actively pursuing IPv6. And the Asia-Pacific region is a little bit further behind, but it's not clear that North America finds a need for IPv6. I suspect that for folks that are doing multinational work that you're going to see IPv6 show up in your infrastructure, probably from either Europe or from Asia. And there are a number of companies that have said that they are going to include IPv6 as part of their product lines and with some sets of deliverables. That's my IPv6 overview, and I think Michael is going to come up from ARIN and talk about ARIN specific stuff, and then we will be available to chat. While he's setting up, I will say that you should believe everything Ed Kern says. Everything that Ed Kern says is true. Ed is king. Yeah, I think so.
Hi, I'm Michael O'Neill. I work in the Registration Services Group at ARIN. We find that our discussions of IPv4 allocations and assignments don't go very far before they touch upon the principles of IPv4 address allocation and assignment that are laid out in RFC 2050. So I want to begin the talk by discussing a little bit of the literature and RFCs for people to review that form the backgrounds to the IANA delegations, IPv6 delegations to the registries. Talk a little bit about the criteria, both the initial criteria for the IPv6 bootstrap phase and the general criteria which will apply after that, and then talk a little bit about the allocations that ARIN has made. The first documents were published in mid-1998, RFC 2373, the IPv6 addressing architecture, and what applies to most folks in this room who may discuss within their groups unicast IPv6 services. RFC 2374 sets up the outline and address format for those unicast addresses. In late 1998, the TLA, the top-level aggregation bits, and NLA, next-level aggregation identifier, the assignment rules for that were set up. And it was within that context, after December of 1998, that the three regional internet registries, or RIRs, set up a series of allocation criteria for IPv6, under which in July 1999, the IETF released the initial IPv6 allocations to the registries. The first phase of these allocations was set up under a bootstrap time period. This bootstrap time period would apply to the first 100 sub-TLA identifiers that were allocated by the regional internet registries to any IPv6 registrants within that region. Within one particular region, whether that be Asia Pacific Network Information Center, APNIC, the RIPE NCC, or ARIN, there would be no more than 60 sub-TLA IDs allocated under these bootstrap criteria within that one particular region. Then the general criteria would apply. One of the first criterion that the document addressed was that the BGP peering relationships for the IPv4 network of the requesting organization must have peering relationships within 3 other public ASs in the IPv4 infrastructure. In addition to that, the organization must demonstrate intention and solid network deployment plans for production IPv6 services within 12 months of the allocation by the Regional Internet Registry, and either one of 2 other criteria: that the requesting organization must be an IPv4 provider to at least 40 sites or customers that would merit or qualify for a /48, an NLA, or a set of bits in which to do aggregation in IPv6 at the /48 level, or have 3 months of 6-bone pseudo-TLA experience and overall 6 months of experience working with the 6-bone group. The general criteria that take effect after the bootstrap criteria time period has been exhausted that would apply to any organization requesting an IPv6 sub-TLA from a regional internet registry are that the organization would have BGP peering established with 3 other IPv6 networks with sub-TLA IDs. The organization must also have reassigned IP addresses from their IPv6 upstream providers to at least 40 downstream sites. Also, that organization must, in addition, demonstrate a clear intent to provide and expand their IPv services within 12 months of the allocation from the Regional Internet Registry. Finally, the allocation status as it exists right now. ARIN in July '99 received a /23 allocation from the Numbers Authority. We have 4 registrants so far, and the 2 /23s I listed at the bottom of the slide are the other regional internet registries. If you have any more questions or seek any more information about ARIN IPv6 registration services, I provided the URL there. Before I wrap up, I wanted to see if there were any questions, I guess for either Bill or me. We have about 10 minutes left to work with, which is good.
Kevin Oberman from ESNet. We do have our IPv6 delegation, our address space, I should say, but thus far getting DNS delegation has been an exercise in frustration. Is there any hope that ARIN's going to be able to get delegations of namespace working one of these days?
Yes, absolutely. I'll relay that to our engineering group, the pressing concerns.
Because I have spent a fair amount of time on the phone, and I've always gotten promises that it's going to happen real soon now.
I apologize.